tutorial by LearnFast Studios.
Welcome back, guys. In this session, I would like to explain you related to the more efficient searching methodology, which you call it as an binary search. Let me take one example. Let us consider this is a textbook term series. For example, I just wanted to go to the page number 245. Normal linear search procedure. What will I do? I will start opening this book from the first page, and then I will check whether this page number 1 is equal to page number 245 or not. If it is not matching, then I will skip to the second page, then I will skip to the third page, and so on and so forth. I need to skip the pages up to 242 to reach to the page number 243, then 244, and then you will be reaching to the position 245. So this is the situation that will happen in a normal linear search. The problem with respect to this linear search is if the number of the elements or the array size increases, the time complexity will also increase parallelly. If the number reaches to the maximum n, in the worst case, that will be in the order of big O of n. That is the problem with respect to the linear search. Then, is there any alternative mechanism to minimize this time complexity for the linear search? Then it comes with a new concept called as an binary search. So this binary search, what we will be doing is, we will consider the first page to be low and then last page to be high. Then we are going to calculate the middle page, and then we will go to that middle page. Suppose if we open the middle page, if the page number is 120, then obviously my page number, what I am searching for, will be on the right side. So then I will leave this particular portion and then directly skip to this particular portion, and then I will only search in the upper half. That is the concept of the binary search, by means of which in the one single iteration itself, then we are going to make this entire section into the half of the section. Hence, we are going to reach to our desired element faster, much faster. So this is the basic idea of the binary search. In order to implement this, we can have a recursive procedure. Otherwise, we can also go with an normal iterative procedure. And in this session, I would like to explain you about the normal methodology. So let me define the binary search. So take down div binary search. As we did previously, we will be passing the elements as well as a pivot as an argument. For this binary search, and then we will initialize low to be 0, high to be length of elements. Now, while low less than high, we will keep on continuing calculating the mid value. Mid value will be becoming like a low plus high whole. It is an integer division. We need to take the lowest positive integer after the division. Then we need to check, there will be three conditions that we need to verify here. Whether the given pivot element present at the mid position or not. That is the first case. If pivot equal to elements of mid, Then we will declare the element is present and then return that position. So in order to return the position, simply our position is at the mid itself. So simply say return of mid. So this is the technique. Otherwise, there is a possibility that pivot can be less than the element of the mid, otherwise greater than the element of the mid. So these are the two other conditions that we need to verify. Now, again, I will be writing down elif pivot is less than elements of mid. That means our pivot element is on the left side of the group. That means our left side of the list, lower half. Then we need to move the high position to the mid minus one, so that for the next iteration we will be again calculating the mid considering the new high value and then new low value, by means of which we will enable the etching process to be done in the lower half. So that is the concept. So let me make it like an now high. I need to update to mid minus one. Why? Because since the pivot element is less than element of the mid, hence we need to search in the lower half itself. So that is a basic case. And coming to the last case, obviously that would be pivot will be greater than the elements of the mid. Then in that case, we need to move the low to mid plus 1 position. Since we already verified with the mid value, and then since the pivot element is greater than the mid value, then we need to search in the upper half. Let me tell you guys one more important thing. In order to perform this whole binary search, you need to make sure one important thing, that all the elements that you pass to be in the sorted order. If the elements that you pass are not in the sorted order, then our concept of searching in the lower half or on the upper half will not be working out. So that is a basic idea, guys. So at this point you need to be very much careful. Okay, let's get back, and then once you come out of this particular while loop, means the low is greater than high. That means there are no further elements to be verified. Once low crosses the high, and then if you cannot able to find out the position where your element is residing, then you can declare like there is a negative, so return minus 1. So this is a basic concept that we will be coding in order to perform this binary search logic. We can also perform the same logic using the recursive methodology. That thing I will be discussing in one more session. Let's make a call to this binary search and then check whether this is working fine or not. Okay, so let me take where is my position equal to binary search of, now let me pass an array of elements. Let me say 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7, and let us check with element 4 and check what will be the return value. If position is not equal to minus 1, means the given element is present in the array, so then I need to display that element's position where it present. So just print the element is present at percentage %d location, comma, it's not comma, it is percentage. The return position is kept in the variable POS, hence I just pass it. Otherwise, simply I will display print the given element not present. That is as simple as it. So this is how we can code. Let us check whether our code is executing properly or not. Just in the code, just have a look. Since this array index starts with 0, 1, 2 and then 3. 4 has been present at the location 3. Now let me check within one more element 6 and then execute it one more time. So now the element 6 is present at the location 5. So coming back, let us also verify the failure case. The failure case is simple. Let me check with 9. Let us also verify one more thing. Let us change this the elements, array of the elements that we pass to an unsorted array and check whether our algorithm is working fine or not. So let us take the values randomly. 2, 1, 3, 4, 14, 3, 14, 4, 9, 8. Now in this case, let us check, let us verify whether we could able to get the value or not. So in the given array 9 is present and I am just trying to verify whether the presence of the 9 is there or not. That is the whole idea of the search. Any searching algorithm will return the presence of a given pivot element. So let us verify that. Let us just run. As per the elements that we pass, 9 is present in the list. Now let us check whether binary search is able to find out the presence or not. See, it is returning the value that the given element is not present even though 9 is present over there. So this will happen in few cases where if you pass the unsorted array as an argument. So that will be the case with respect to this particular binary search algorithm. So my dear, please make sure before you execute this binary search algorithm, make sure that whatever the elements that you are passing as an array, that has to be in the sorted order. Otherwise you can simply make sure that you just write down one sorting algorithm and then pass that whole array to that sorting algorithm, and then whatever the resultant value you pass that array. That's it guys. So this gives a comprehensive understanding of the binary search algorithm as a whole and then its implementation.